Okay, we have problems numbers 1 and 2 on the week of May 4th, assignment A, I guess. So this is the one that's got some data about level of participation, extracurricular activities, and where the people live on campus. So they asked for a little data. So the first was what percent of on-campus participate at least one or more. Just reading the chart, the 17 plus the 7, 24 out of 33, 72%. The off-campus, 25 and 12, 67, or 37 out of 67, 55.22%. Then they drew a little plot, which I'm surprised they didn't make you do, actually, based on that, and asked you to summarize. And I think the picture, and as well as that data, would show it appears that there's a difference, right? But be specific what that difference is. So there appears to be an association between residential status and level of participation. It appears the on-campus students are more likely to participate. We have since learned that there are tests to figure this out rather than looking at pictures, small sample sizes, right? So they ran a test, they gave us the null and the alternate, and they got a p-value of 23%, greater than 5%. So we're going to fail to reject the null, which means there is no evidence of an association between residential status and extracurricular activities. Pretty straightforward. Problem number 1. Hopefully we did okay with that one. Problem number 2 next. A little probability question. There are 6 men and 3 women in this very small company. 6 men, 3 women. And they're going to pick 3 people to go on this trip. And they picked 3 women. There are concerns that no men were picked. And it says calculate the probability of randomly selecting 3 people from a group of 6 men and 3 women will result in selecting 3 women. So there's only one way to get 3 women. It's 3 women, you're picking 3, you've got to pick all 3 of them, which is the same thing as 3 choose 3, which is 1. The total amount of choices is 9 people choose 3. So you got 1 divided by 9 choose 3. There's a 1.19% chance of this happening. So the question is based on that, is there reason to doubt the claim that it was done randomly? Well, yep. We've talked all year about this 5% cutoff. I know it's a random cutoff, sort of, but the probability of it happening by chance is very low. If you're in this company, you're going to say, hey, there's only a 1.1% chance of this happening by chance. Probably didn't happen by chance. Probably happened some other way. Part C does a little simulation instead of the actual probability. They roll a dice. Since there's 6 and 3, 2/3, they thought using 1, 2, 3, and 4 are men and 5 and 6 is women, and they roll the dice. That's great if you only do it once. But once you do it once and you do it again for the next person, you haven't changed the probabilities, right? So using dice assumes replacement. It's the same thing as picking someone out, putting them back in, because those probabilities don't change when you use the dice, but they should change in the real world. Pick one, they're gone, right? So the best answer is no. Using dice assumes replacement. Once a woman is picked, or a man, doesn't matter which one, the probability would then change on the next roll, so you'd have to do something different. In real life, in the next pick, there should be no replacement. So that's it for 1 and 2.